Now we're going to talk a little bit about classifying quadrilaterals. Here's the deal. Quad, you take Latin. Quad means four, okay? So quadrilaterals are four-sided. So any four-sided figure is a quadrilateral, period. Now, I love this diagram. And here's what it says. Quadrilateral it can branch into two groups. And so we'll talk about all these different shapes. But what do you know about all quadrilaterals? Okay, one is that it is a four-sided polygon. Four-sided polygon. Number two, the sum of the interior angles is 360 degrees. That means this angle plus this angle plus this angle plus this angle. No, they're not the same. All of them added together is 360 degrees. So that's what all quadrilaterals have in common. Every single one of them. Any four-sided figure has that in common. So when we branch out, we have a class of quadrilaterals that are called parallelograms. And all parallelograms have a couple common similarities. All parallelograms, every single one of them, is that opposite sides are parallel. And remember, the notation for parallel is those arrows. So that means we can draw these arrows, meaning these lines are parallel and these lines are parallel. And all parallelograms, opposite sides are congruent. Now, congruency, my marking is if this is one tick mark and this is one tick mark, that means they have the same length. And this is two tick marks, this is two tick marks, these guys have the same length. So this diagram says it for us. So this is my diagrams, this is the words that match my diagrams. Both are extremely important, okay? All right, now, if it's a parallelogram, you have a couple different options. Can you break it down even further? Well, a rhombus and a rectangle. Okay, a rhombus fits all these criteria. I can still say that they're parallel. I can still say that they are opposite sides are parallel, opposite sides are congruent. That still holds true. But what I can also say about a rhombus is that all sides are the same. So all sides are congruent. So not only are opposite sides congruent, but all sides are congruent. All of them. So if this is 4 inches, this is 4 inches, 4 inches, and 4 inches. So a rhombus takes into account that not only does it meet this criteria, but now all sides are equal. Okay? In a rectangle, what is special about a rectangle? Well, it still meets these criteria. Opposite sides are parallel, opposite sides are congruent, but in a rectangle, I know that I have all angles are 90 degrees. Okay, so it still meets the criteria plus 1. Still meets the criteria plus 1. Now, look at your square. Your square, notice how this diagram is going. It's saying that a rectangle and rhombus make a square, and that's true. So a square is very special in that it fits all the criteria above, okay? Opposite sides are parallel. Opposite sides are congruent. It fits the criteria of a rhombus that all sides are congruent. And it fits the criteria of a rectangle that all angles are 90 degrees. So a square is a rectangle and rhombus coming together. Still a parallelogram, fits all the criteria, but now we're merging them. So the square brings into all sides equal or congruent, and all angles are 90 degrees. So we're merging them together. Now, that's a parallelogram. A trapezoid is not a parallelogram. It will never be a parallelogram. It doesn't fit the criteria. A trapezoid, both sides aren't congruent, opposite sides aren't parallel, opposite sides are not congruent. So a trapezoid is unique in that it's still a quadrilateral. It still has 4 sides. It still has still has four sides. It still meets the criteria that the sum of the interior angles is 360. But a trapezoid is special in that only one pair of lines is parallel. Opposite. Only one pair of opposite lines is parallel. So this is parallel and this is parallel. That's the definition of a trapezoid. One pair of lines that are parallel. Now, an isosceles trapezoid is unique in that it still meets this criteria. One pair of parallel lines. Okay, here. And these guys are congruent. So that would be the non-parallel side are congruent. And that is the overview of quadrilaterals. So we're going to kind of look at it in more detail, but I love this because it gives us the overarching picture.